Hello, grade 9. In this video, we will talk about dispersion, unit 3 in statistics, okay? Here, in the first, if I have two sets, set A and set P, okay? Set A represents the maximum 5 marks of 5 students in class A, okay? And set P also represents the maximum 5 marks of 5 students in class P. Now, I need to calculate the mode, median, and mean for each set of them, okay? So we have studied before how to calculate the mode, median, and mean in grade 7, okay? So the mean equals the sum of values divided the number of the values. The sum of values divided the number of the values, okay? And also the median is what? The median is the middle value in the set. After ordering them, ascendingly or descendingly, both of them are right, okay? And the mode is the most common value. So here this table shows the mean, median, and mode for the two sets A and P. Okay. Here the mean of the first set, set A, equals 32. If you calculate the mean of the set A, we get 32. How? 29 plus 30 plus 26 plus 35 plus 35 plus 35 divided 5, because I have 5 values here. 1, 2, 3, 4, 5. So the mean equals 32. Also, the mean of the set P is what? Is 32. If you add the 5 values here divided by 5 equals 32. Now, the median of set A. The median, I said what? The middle value in the set after ordering them, okay? Ascending, descending, I said both of them are right. So the median here is 35, okay? 26, 29, 35, 35, 35. So the middle value is 35. Also here in set P, the middle value also is 35. Now, the mode, I said what? The mode, the most common value. So the most common value in set A is 35. And here, the most common value in set P also is 35. Now, we know something. The two sets here are different. Set A, set P are different, okay? But the mode, median, and mean have the same values, okay? But the two sets have the same mode, median, and mean, okay? So mode, median, and mean, okay, are unable to describe the data, okay? I need now to describe the data in set A and set P. So we know something, mode, median, and mean only are unable to describe the data. Now, we need new measures to describe the data. In this lesson, we will talk about dispersion. So, what is the meaning of the dispersion? Dispersion of a set of values. What is the meaning of dispersion? Dispersion is the difference among the values. So dispersion is small if the difference among the values is little, okay? But the dispersion is great if the difference among the values is great, okay? But the dispersion equals 0. The dispersion is 0 if all values are equals, okay? So there is no difference between them, okay? So dispersion is 0 if all values are equal, okay? Now we'll talk about two measures of the dispersion. Now, the range, okay, and standard deviation. So dispersion measurement we will talk about in this lesson two something. The range and standard deviation. The first, what is the meaning of range? Range here equals the greatest value minus the smallest value. Greatest value minus the smallest value. Okay. For example, here if you have the set values of the set A are 60, 58, 62, 61, and 59. What is the greatest value here? Greatest value in Sarah is, yes, 62. And the smallest value is 58. So the range equals 62 minus 58 equals 4. But if you have another set, like set P, 72, 78, 46, 65, and 39. So the greatest value here, 78, and the smallest value is 39. So the range equals what? The range equals 78 minus 39 equals 39 also. Oh, the value of the range here is small, but the value of the range here is 39. We know something, okay? The set B or the value of the set P, okay, is more divergent than set A, okay? So, I have some advantages of the range and disadvantages of the range. The advantages of the range is simple and easy. It's easy rule, okay, and simple, okay, simple and easy. But the disadvantages of range, the range is dependent on the greatest value and the smallest value only, dependent on two values, the smallest values and the greatest values only, and therefore the range doesn't have a full idea about the dispersion of the remainder values. Okay, so I have another idea another measurement, standard deviation. So what is the meaning of the standard deviation? I have to calculate the standard deviation of the two another set, like set 2. The first, calculate the standard deviation to a set of data. Here, the data must be individual values. So, the rule of the standard deviation and it's denoted by this sample, sigma, okay? This is called what? Sigma, the sample of the standard deviation, okay? And here, standard deviation sigma equals square root of what? Summation x minus x bar raised to power 2 over n, where x bar means what? Means the mean. X bar is the mean, okay? And n, number of the values, okay? Here, for example, calculate the standard deviation for the values 12, 13, 16, 18, 21. Here, the values are individual values. So, I need to calculate what? Calculate the standard deviation. So, I must in the first calculate the mean. And I said before the mean equals the sum of values divided the number of the values. So, x bar, I mean what? The mean. X bar equals total of these values divided their sum. So, the sum of them, 12 plus 13 plus 16 plus 18 plus 21 divided 5, because I have 5 values here, okay? So, x bar equals 80 over 5 equals 16, okay? Now, I need to find what? Find the first column here, x, the value of the values, x, our values, 12, 13, 16, 18, 21. Here I have a new column, x minus x bar, okay, x bar here equals 16, so 12 minus 16 equals negative 4, okay, 13 minus 16, negative 3, 16 minus 16, 0. 18 minus 16 equals 2. 21 minus 16 equals 5. Okay. Now I need to what? I need to find the summation of them. Okay. Raised to power 2. Here in the first I will find what? I will find the x minus x bar raised to power 2. So negative 4 power 2 is 16, negative 3 power 2 9, 0 power 2 0, 2 power 2 4, and 5 power 2 25. Now the standard deviation equals square root of the summation x minus x bar raised to power 2 divided n. So I need to find the summation of x minus x bar raised to power 2. If you find that, we get 54. 16 plus 9 plus 0 plus 4 plus 25 equals 54. So we will substitute by the value of x minus x bar raised to power 2 in this rule. We get sigma equals square root of 54 divided 5. I have 5 values here, okay? So standard deviation equal root 54 divided 5 equals root 10.8, approximately 3.286. Okay, so the value of the standard deviation here 3.286 for the individual values them. Okay, now I have another idea how to calculate the standard deviation of frequency distribution. Frequency, I mean here repeating, frequency distribution. For example here, in the first our rule to calculate the standard deviation of frequency distribution, sigma equals the square root, okay, of the summation x minus x power raised to power 2 times k over summation of k. Here, k, what is the meaning of k here? What is the meaning of k? K here represents the frequency. K represents the frequency. And x bar represents the mean, okay? And x here represents the values of the, in the set, okay? The values of the set. For example, here, the following are the frequency distribution for a number of, okay, defective units which found in 100 boxes of manufactured units, okay. The first, this table, number of defective units, okay, 0, 1, 2, 3, 4, 5, okay. Here, 0, I have 3 boxes. 1, I have 16 boxes, okay. 2, I have 17, 3, I have 25, 4, 20, and 5, I have 19 boxes, okay? So the meaning of repeating, the meaning of the frequency distribution here. Here I need to find the standard deviation, okay? And the first I will calculate what? Calculate the mean, x bar, okay? So the x bar or the mean, to calculate it, I will find in the first the summation of what here. The mean equals summation x times k, Here I have this table, the number of the defective units, the set, okay, and the number of frequency, like here, 3, 16, 17, 25, 20, 90. So I will multiply x with k, okay, to find the summation of them. So k, 0 times 3 equals 0, 1 times 16 equals 16, 2 times 17 equals 34, 3 times 25 equals 75, 4 times 20 equals 80, and 5 times 19 equals 95. The summation of them equals 300, and the summation of the frequency is 100 boxes. 100 boxes from the question here, okay? 100 boxes. So x bar equals 300 divided 100. 3. 100 divided 100 equal 3. So the mean equals 3. Now I need to find x minus x bar. A new column represents x minus x bar. So set 0 minus 3 equal negative 3. 1 minus 3 equal negative 2. 2 minus 3 equals negative 1. 3 minus 3 equals 0. 4 minus 3 equals 1. 5 minus 3 equals 2. Okay? So I will, the second column, the next column represent x minus x bar raised to power 2. Okay? So negative 3 power 2 equals 9. Negative 2 power 2 equals 4. Negative 1 power 2 equals 1. 0 power 0 equals 0. 1 power 2 equals 1. And 2 power 2 equals 4. The next column, find x minus x bar raised to power 2 times k. Okay? So, where is the k? Here. 3 times 9, 27. 16 times 4, 64. 17 times 1, 17. 25 times 0 equals 0. 20 times 1 equals 20. And 19 times 4 equals 76. Okay? Now, I need to find something. The summation of the frequency 100, and the summation of x minus x bar raised to power 2 times k equals 204. So sigma, or the standard deviation, equals 204 divided 100. I will substitute by the values of frequency, the summation of the frequency and summation of x minus x bar power 2 times k in this rule. We get sigma equals root 204 divided 100 equals approximately 1.428 units. Okay, so this rule to calculate the standard deviation of frequency distribution. But if we need to calculate the standard deviation of a frequency distribution of a set, okay, like what? Here the sets 0, 4, 8, 12, 16 to 20. Here I mean its values here represent a set. Represent what? Represent a set. In this set I have 0, 1, 2, 3. Okay. Here this set represents 4, 5, 6, 7. And the same idea. Okay. Now I need to find what? To calculate the standard deviation. You have this rule. And the first you must be calculate what? Calculate the mean. Calculate the mean. Okay. So here the mean, to calculate it, enter first here the set here 0, 4, 8, 12 and 16. Frequency is 2, 5, 8, 15, 20, 10. Now I need to find the point. Is the same important. It's very important. This point is very important. How to calculate center of the set. Center of the set. Here I deal with sets, not values. Okay. So the difference between each set is 4, 0, 4, 8, 12, 16. So the difference between each set is 4. Divided 4 by 2. Divided the difference by 2 equals 2. So I will add 2 to each set. So the center of the set, 0 plus 2 equals 2, 4 plus 2 equals 6, 8 plus 2 equals 10, 12 plus 2 equals 14, 16 plus 2 equals 18. So the center of the set equals this column. Okay. Now I need to find what? I need to find the x bar. So x bar equals here center of the set times k. Center of the set. Center of the set, not set. Center of the set times k. 2 times 2, 4. 5 times 6, 30. 8 times 10, 80. 15 times 14, 210. And 10 times 18 equals 180. Okay. So the summation of x times k equals 540. 504, and the total of the frequency, the summation of the frequency from the problems is 40 students. 40. So x bar equals 504 divided 40 equals 12.6. Okay. Now I will find what? I will find x minus x bar, but here x what represents the center of the set, the center of the set. So 2 minus 12.6 equals what? Okay, equals 10.6, negative 10.6 or 10.6 as you like. You can start with 12.6 minus 2 or 2 minus 12.6. Okay, finally you will find the square of this value. 6 minus 12.6 equal negative 6.6, and the same idea we get x minus x bar. Now I will need to find x minus x bar raised to power 2. Okay, 10.6 power 2 equals 112.36. 6.6 power 2 equals 43.56, and the same idea of each of the following values. Now I will find x minus x bar raised to power 2 times what? Times k. Okay, so here 2 times 112.36 equals 5 times 43.56 equals this number. Okay, also 8 times 6.76 equals this idea. Okay, and complete the remainder of the column by the same idea here. Now I need to find the standard deviation. Okay, the same rule, the square root of x minus x bar raised to power 2 times k divided the summation of the frequency. So the standard deviation equals 817.6 divided what? Divided by 40. The summation of the frequency here. We get the standard deviation equal approximately 4.52 marks. Okay, so I have 3 methods to calculate the standard deviation. First one, if you have individual values. Second one, if you have the standard deviation of the frequency distribution or frequency distribution of a set. I wish you have a good idea about this lesson. Goodbye.